Well, today I'm doing some audio equipment here. I've got a Denon receiver. This one happens to be an AVR788, AVR788. And as you can tell, it's got the blinking red light, as they call it on the internet, the blinking red light of death. I can manually hit it. It will go green. The receiver will attempt to power up. Then it goes back to a blinking red light and it shuts itself down. So how do you know where to even start on a problem like this? It could be so many different things. The most common problem in a receiver like this, or any audio receiver, is one channel that's blown due to a bad speaker wire, overdriving, a bad speaker. They're just little output transistors, and if you crank it up a little too much, sometimes they lose their junction and they short in most cases. So let me show you a couple quick steps to do some troubleshooting on the main power amplifier output stages, some quick tests you can do. So I've got the camera zoomed in here to just basically one of the output stages, which is these two transistors. These are the main power output transistors for one channel. This one looks like it's got probably, let's see, 1, 2, 3, 4, 5, 6, 7 total output channels. They're each driven independently. They have their own little push-pull amplifier. So you'll typically notice the two final output, or the two main output transistors, along with a bias transistor in the middle that's used as a bias diode to compensate for the temperature changes, to keep constant bias on the output transistors, to keep them operating in the correct stage so they don't turn into a class C. They want to keep it in a class AB amplifier to keep a minimal amount of bias on each transistor. So each transistor conducts just over 180 degrees of the audio wave. The first thing that you can do is with your ohm meter, and of course you can't see my ohm meter right now, but you can put your ohm meter in the ohm or even the continuity or diode settings, and with the unit off and unplugged, of course, you'll see 3 leads that come from each transistor. As you're viewing the front of the transistor, the left-hand lead is always the base, or if it's a field effect transistor, the gate. The center lead is always the collector. The right hand is always the emitter. And that goes for these plastic packed transistors. These are what I call a TO3P, TO3 case in a plastic case. So the easiest thing to do is just check for a short between these two leads, collector and emitter. Go through and check this on all the output transistors just to see if any of these happen to be shorted. If you do measure a short, then you know that that is the transistor in suspect. I always change both at the same time, as well as you need to go down. There's like a driver transistor down here. There's some resistors. You should always check the small value resistors. These resistors down here are very low value resistors, under 1 ohm each. Those are the emitter resistors, and they allow the transistors to be not quite matched perfectly but still produce a good audio output waveform. The other thing that you can do is, if you notice, there is a little connector at each one of these amplifiers, and that's the bias test point for the factory, and that's where there's a potentiometer right here. Is they'll put a meter, a plug on these two test points, and they'll adjust the potentiometer for a certain number of millivolts of bias on the output transistors. And so this test can be done with power, where if you use your common ground, like I've always talked about, just clip your negative lead somewhere on the metal chassis, and then with your positive lead you can measure. In most cases the center lead's not used in this one, but there's a left hand and a right hand lead. You can just measure one of those two leads while the power's on. You should have near 0 volts, usually just a few millivolts. If you have anything more than that, then suspect a problem. Now on this particular amplifier, every one of these that I've measured, you can see there's one here, there's one here, there's, I don't know if you can see them with parts in the way, but there are the little test points all over the place, and they all seem to have about a 25 volt bias on them equally, and that's what's shutting down the amplifier, because there is a circuit that monitors for potential DC output on the speaker leads, and if it senses that, it disengages the speaker relay and shuts the unit down. So let's talk about how do you determine what the possibility of your failure might be. let's take some power supply voltages first and see what we've got. So I've got my voltmeter sitting here. It's on the DC volt range. I put it manually in the 60 volt range so I don't have to wait for it to auto range. I've got the power on to the unit, and what I'm going to do is I'm just going to put my probe on the center lead of one of the two output transistors, and I'm going to fire the unit up, and I want to see in the 50 to 55, maybe 60 volt range, so that's good. I've got 52 volts right there. And then I want to measure the other transistor, which is the opposite. It's going to be a negative voltage. So I should see about the same voltage negatively, so I've got minus 52 volts there. So when this thing's up and pumping, there's a potential of about 100 volts output on the speaker, so you do want to be careful also when you're probing around these things. So just for the heck of it, let's take a look at the emitter voltage. Like I said, it was about 25 volts, 24.6. Then the unit shuts itself down, and you see it start dropping there. The emitter on the other transistor should be exactly the same, so it's getting a positive offset, which is what's shutting the amplifier down. So I've determined that it's not the main high current power supply to the audio output transistors. One leg of that's not missing. It does have the plus and minus 52 volts on each one of the output transistors. So let's look at some of the other lower voltages. So what's nice about this Denon unit here is, I don't know if the camera can pick it up or not, but the pins on this little sub power supply board are labeled. So there is, the first pin right here is plus 15 volts. The second pin is minus 15 volts. Third pin's no connection. The next one is, looks like S2 or possibly 12 volt ground. And then we've got 5.6 volts down here, a 5 volt power supply. And so let's take a look at some of these voltages and see where we stand. Now once again, I am on negative ground. I'm on the first one, which is labeled plus 15 volts. And I've got 1.4 volts. That could definitely be a problem. Let's go look at the second one before it shuts down. I just saw minus 15 just for a second. So that's going to be my main concern, is why am I not getting plus 15 volts out to the processor? And that would definitely screw things up a little bit. Okay, so one thing I did notice, there's a little cutout here on the side of the unit, and I see where it's labeled 7815N as well as 7805N, and those 7815 is a 15 volt positive regulator, and that happens to be the voltage that I'm missing. So I want to go ahead and check right there and see if I've got voltage going into that regulator. Okay, it's going to be hard to do. I'm going to hit the power. I'm going to put the probe on there very quickly. And it looks like I've got about 25 volts there. So next I'm going to investigate, is the regulator actually bad, or is it something else in the circuit? Unfortunately, to get to that little regulator circuit board, that little power supply board, everything's got to come off of this back panel. All the screws have got to come out for the speaker jacks. Everything's got to come out for all the audio video input output jacks. The power and the whole back panel's got to come off so I can gain access to that little circuit board. Well, I was able to disconnect the speaker lead assembly and get it back out of the way. I've got everything disconnected from this little sub power supply board, and I've only removed just a couple screws in the back here so I can get the board and just lift it out of the unit. So I've got the board completely out of the unit here, and I've done continuity tests from the connector, the one that we could see right down here that was labeled 7815N. I have followed it, and it does go through a couple diodes here to the input of this regulator right here. And I see no defects there. In fact, I measured the voltage on the diodes. I've got 25 volts on the input pin of this regulator, and I still have only about 1.5 volts on the output pin. So I'm going to go ahead and replace that regulator. And I'm going to change it just as you would, without any fancy tools, just a soldering iron only. Okay, so the first thing is I'm just going to simply remove the screw from the defective regulator IC. I'm just going to tip it forward a little bit to make sure it's not touching the heatsink in any way. And I'm doing this blindly, so hopefully you can see it, but I'm going to try to actually just heat up all 3 leads simultaneously here. Sometimes you have to add a little bit more solder, but once you get all 3 leads molten, you can actually pull it right out of the board, and you can just kind of wick the excess solder out of the way. Occasionally, if you need to, you can reflow the solder pads. Let me show you how to do that real quickly. If you don't have any other way to clean up this mess, just add some solder, and the fresh flux will actually cause it to kind of wick away. But you can see how nice and clean those pads are. Sometimes if you're lucky enough, you can even restore the hole. I got the hole, there it is. You just got to work at it just a little bit. You can get the surface tension to break. No, that one doesn't want to do it. So in that case, if you can't restore the hole, just take something like a little dental pick. That'll restore the hole back to you. Hopefully you can see that there. But it's nice and ready for the new regulator to go in. See if it'll refocus on there. But you can see all 3 holes are open right up there, ready to go. There's no solder bridges or anything now. Okay, so there is my new regulator, 7815. I've put some fresh heatsink compound on it. I always want to make sure you tighten it down until you can actually see the heatsink compound oozing out around it. Let's go ahead and solder it back into the board now. This one's great. The leads are just the right length. I don't even need to trim them. So we'll put it back in the unit and we'll see where we get. Okay, so I've got the unit back together here. I've left the speaker terminal board out of it so I can get easy access down here, but I've got my probe on the 15 volt output source. Power the unit up, and I'm seeing a little over 14.5 volts, so I'm pretty happy with that. Unit has not gone into shutdown. Okay, so I've got the unit back up and running. Still haven't put the speaker terminal jack back in it yet, but we can make some measurements here. So there's our 55 volts on the collector of the output transistors, and we want to see near 0 on the emitters of those. Let's test that little test point as last time. 0.01 volts. I've got it in the 60 volt range right now. And so let's go ahead and let me get my ground lead. Now we'll look at the bias of the output transistors here real quick. Put it in the millivolt range. And it's just a matter of measuring between the 2 in pins. So I've got 4 millivolts of bias on that output transistor, or that power amplifier. Let's see if I can get down into the bottom here. Measure this one down here, hopefully in my hand. So same thing, 4 millivolts of bias. So that is the idling current or bias test point, and that potentiometer right up here is what adjusts that. So typically you want to see, and that's just me holding the probes loose, is that much voltage on the meter. So typically what you want to see is anywhere between about 5 and 15 millivolts of idling current on the output transistors on these newer modern amplifiers. Okay, I've got the unit all ready to go now, and we'll power it up, and we should get the green light to stay on solid. There we go. That's the speaker relay engaging that last click that you hear. Everything's working great. Appreciate your watching my video on the Denon AVR788, and as always, I appreciate all your views, your comments, your support. Don't forget, follow me on Twitter, NorCal715. I can't answer every conceivable question you send me, unfortunately, but I do answer as many as I possibly can. With your help, we can keep these things out of the recycle bin, out of the landfill. Everybody have a great day. Once again, thanks for watching. Bye-bye.